So the next sensor we're going to take a look at is actually located at the back of the microbit. Look right above the ground pin and you will see a little small little device on your microbit labeled accelerometer. And if you have a smartphone such as like this, right, a normal smartphone, you will see that every smartphone also has an accelerometer. And what an accelerometer does is basically it can detect the orientation of your device. So you know how you play racing games and you might take a smartphone and tilt it. The Nintendo Wii was also really famous for this. That's using the accelerometer to detect which way a device is tilting, or in the case of a microbit, we've used it for projects such as shake, so you can detect how a microbit is shaken. But we can do a lot more complex stuff with the accelerometer. We can see how fast any object is accelerating and what orientation it's in. So let's explore some of these possibilities, and in the next video we'll be making a really cool project using the accelerometer. So we hop on over to our computer and we click on oops, sorry about that. We'll click on input and we'll go into acceleration. So this is the first one we'll explore. So I'll just pick out show number and I'm going to drop acceleration in there. And this is quite interesting because the microbit can give us acceleration in 3 different axes. It'll give us acceleration in x, y, and z axis, in the z axis. So what that means is this is the x axis, this is the y axis, and this is the z axis. And depending on exactly which axis this is mounted, you can measure the acceleration. Maybe you want to mount your microbit to a car, a moving car, and you just want to see how fast it accelerates in corners, right? So not how fast it accelerates in terms of speed, just how fast it corners. So we might mount the microbit straight like this in the on the car, lying flat, and now we know that this is the y-axis and this is the x-axis. And the car, so if this is mounted on the car like this, we don't care about the y-axis, we only care about the x-axis acceleration, which is side to side. So maybe you can more accurately measure the acceleration of a car turning by just measuring the x-axis. Or alternatively, imagine you don't want to measure, you don't want to include how fast a car accelerates in terms of turn, you only want to see how fast the car accelerates in terms of going forward and backward. Then you would use the y element over here. So I click on y. So again, I'm just showing you how you can show this on the screen, but yeah, anyway, I can also do it on the simulator. If I'm moving my microbit slowly, you can see how it reacts to that. You can also see how it works on the microbit over here. Based on how I move, you can see the acceleration right here. You can also see the strength of the overall acceleration. Okay, so for our next exploration, we're going to look at on shake. In fact, we've used this multiple times, but we're just going to explore it once more to understand every single option in here. So I'm just going to drag in show icon and I'm going to go on shake and look at the various options we have here. We have shake, which we've explored. We have logo up, which means if the screen is pointed upwards like this. We have logo down, which means if the screen is pointed downwards, so upside down. Screen up, so if is it facing up, like up as in towards the sky. Screen down, is it facing down towards the ground. Tilt left, so this is the microbit, is it tilted to the left side. Tilt right to the right side. Free fall, this one's actually quite interesting. So you can detect the microbit falling. So imagine you want to use this as a health sensor. You can mount it on like elderly people, and if they fall down, that's a free fall. You can maybe have a siren that starts blaring. So that's one project idea for the free fall section here. 3G. So if you've ever seen an astronaut, they'll often talk about the word G, and G means gravity. So it's the acceleration caused by gravity, and like most of you might know, the acceleration caused by gravity is 9.8 meters per second squared. So a typical astronaut experiences quite a few G's, which means multiple times Earth's gravity on a space flight. So if you want to measure 3G, this is how hard you're shaking the microbit. You could have something activated at 3G, 6G, which is about twice as much, so much harder, and 8G, which is very, 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 very hard. So you can measure G's with this microbit as well. Again, you could have a very rudimentary G sensor on this. Again, you can attach it to a car, and as you're cornering, you can see, okay, if it's 3G, you can have we just explored bar graphs. You can have a bar graphs. If it's 3G, there's a small little part of the screen lighted up. If it's 6G, more of the screen lights up, and if it's 8G, the whole screen lights up. Or you could also have like a rudimentary space flight G counter, which will do the exact same thing. Show more of the screen depending on how many G's are present. So yeah, that's the accelerometer. We're gonna create a really cool project called Flip the Pancake next. Stick around and hope to see you in the next video. Thanks.